This is the OCR freestanding maths qualification level 3 thing from, I don't know, whatever it is. It's fine, let's just do it. We divide everything by 2, just divide all three sides by 2, then take away 1 from all three sides. You've got a calculator, you can use it if you desperately want to. You're going to get this answer. Train is going along this. On the formula book, you have the Suvat equations, so we're given a final velocity, initial velocity, a distance. So that sounds like this equation might be quite good, nothing to do with time. Asking about acceleration, so okay, well, 18 squared equals 3 squared minus 2 times a times 175, because the train's moved 175 meters, right, to get from the start of the station to the end. So that's what S is. Of course, you can solve that, you get A is this. And then the time taken for when the train starts to move. So now this 3 is irrelevant. Starts to move means its initial speed is 0. Final speed is 18. We're looking for a t here. Let's just use v equals u plus at. So 18, 0, 0.9 from what we worked out before. And we'll work out that t is 20. Next, we have a line of 9 students. 1, 2, 3, 4, 5, 6, 7, 8, 9. The middle one has to be the captain. The vice captain has to be on either side. I'll just put him on here for now. And that means there's 1, 2, 3, 4, 5, 6, 7 remaining students to sort, and there are going to be 7 factorial ways to do that. But you could put the vice captain on either side of this guy, so just times this by 2 to get both situations, and you'll get this many ways of doing it. For number 4, show f1 equals 0, so put 1 into this thing here, and just calculate it, you get 0, good. Hence solve the equation. If x minus 1, sorry, if f of 1 is 0, that means x minus 1 is a factor by factor theorem. So therefore, you can divide this by x minus 1 if you want to. I tend to not bother, I just spot it by writing out something like this. This must be a plus 12 because minus 1 times plus 12 is minus 12. This must be a 1x squared because that makes a 1x cubed. And now to figure out the x's, just say, well, okay, currently I've got minus 1x squared. I need 6x squared, so I need a plus 7x in there to make these terms balance this. The 5x will also match if you try it. This is easy to factorize, probably one of the first ones you ever did. It's x plus 4, x plus 3. So the solutions are 1, minus 4, and minus 3. Good. Question 5. So let's first replace 2 theta with x, which means we're looking in the range 0 to 720 by doubling everything to get 2 theta. Do cos inverse of 0.6 to find this answer. And now cos is the one where you do 360 minus that number if it's positive to get the next one, which is this. And then just add 360 to both these numbers to get the remaining 2. And then, of course, if x is 2 theta, divide everything by 2, and you get all these answers. You can use the graph if you prefer, if you draw the cos graph out, or you can use cast diagrams. It doesn't make a difference to me. These are the 4 answers you're going to get. And then cos squared, of course, is 1 minus sine squared. Expand that out, rearrange, you get this. Imagine this in your head as 12y squared minus y minus 1 equals 0. You can factorize that. It factorizes this. I just kept the signs there. So therefore, sine theta is equal to either 1 over 3 or minus 1 over 4. Do sine inverse in the calculator to get this, and then sine, you want to do 180 minus this number here to get this, and then do it again here. I got minus like 15 here, so then I just added it to 180, because again, I have the sine graph drawn in my head, which allows me to do that, or use cast diagrams. Then add 360 to the minus 14 you originally get, you get this, and there's the 4 answers that you're going to get for this question. Number 6 then, so draw a massive probability tree diagram. That's really annoying to do in PowerPoint, but there it is. It's 3 free marks, I guess. Calculate probability that you should just stop exactly once. That's either stop, don't stop, don't stop, or it's don't stop, stop, don't stop, or it's don't stop, don't stop, stop. I think of it. I don't know why that's there twice. Oh well. This time this is that, this is that, this is that. You can add them all up. You get this as your answer. Number 7 then. So 3-way Venn diagram with W, C, and D. Put 15 in the only walked, 9 in the only cycled, 12 in the only drove, 4 right in the middle, and 6 in the W and C up there, but not D. Add those numbers up, and I think you get 46, which means 14 people are missing from the original 60. Apparently everyone uses at least one form of transport, so there's nobody on the outside. And now also apparently this area is equal to this area. That's what the paragraph says. There are 14 missing, so therefore 7 and 7 are going to be these two, and the answer is 7. 8. So if dy by dx is that, then we're going to integrate to find y. Integral of that is 2x, that's 2x squared, that's x cubed. So we get this plus c, of course, don't forget. This means when x is 1, y is 2. So you just put that information in, you get this. which is this, which turns into that, and then you just put that into the original thing, and you get y as that curve there. Good. Next one is going to be given that y equals 4 log space 3 of x, rearrange, divide both sides by 4, and then raise both sides to the power 3, and we get this here for x. Write this as a single number, so put this 2 up there, following the log law that says you can put the numbers in here at the front up there, which I could have done up here, I guess, but didn't bother. So this is log space 10 of 5 squared, plus log space 10 of 16 to the power of a half. Moving these numbers at the top, 16 to the power of half is the square root of 16, which is 4. That's 25. When you're adding logs, you can multiply the inputs. So this is log space 10 of 25 times 4, which is 100, and log space 10 of 100 is just 2, because 10 squared is 100. The equation this has a solution this, determine the value of a. I was quite confused by this question because I forgot that we had a calculator, and also I think maybe I forgot that because this bold text suggests to me that you're not allowed to use one. But apparently the way to do this is just type in the 2.58 root of 17. I just said that 3 squared is 9 and 3 cubed is 27. 17 is in the middle, so therefore if this is an integer, it has to be 3. Not quite perfect logic, because 4 squared is 16 and 4 cubed is 64, and that's technically in the middle of those, although it's clearly more likely to be 3. But yeah, since you had a calculator, you can just solve this one. It was a dumb question. I don't really understand it. Find the coordinates of the intersection, so set this equal to that. Make everything 0 on one side, divide everything by 2, factorize, and you get these two solutions here of 1 and 5. Put those 1 and 5 back into either one of these two things to find the y coordinate. You get these two y coordinates. And those are the coordinates 1, 1, and 5, 9. I probably should have written those as coordinate pairs, but oh well. Find the area of intersection. Now, looking at this graph here, this factorizes to x minus 2 all squared. So it has a double root at 2. So it's a quadratic that goes down to 2 and back up again. And 4 here. This is an upside down quadratic at minus 6 and intersects it at 1, 5. So it must look like this. This is 2, this is 1, and then this is 5 over here as x coordinates. So to work out this area here, I'm going to integrate the upside down curve between 5 and 1, and then take away the integral of the correct way up curve between 5 and 1, which looks like this. If you're integrating between the same two bounds, you can just merge the equations together. So minus x squared, sorry, minus x squared is minus 2x squared. 8 minus 4 is 12x, and so on. I factored out minus 2 from here just to make the numbers easier, integrate everything, put in the 5 and the 1, type that into a calculator, and you get this here. I used my phone, which is why I got this horrific mixed number. But in any case, it's fine. We get 2 marks for doing a bit of plotting. I just made 1 each box across here to get a 10 there, and 2 each box up to get a 16 up here. And then I did a bunch of plotting using that information. It looks a bit like this. Then I drew a terrible curve in PowerPoint because PowerPoint has no particularly decent curve drawing feature. And then I got really confused by this question, but apparently something that is in the spec for this exam, which I've never looked at before, obviously, is instead of trapezium rule, is to draw rectangles like this and use those to estimate the area, which is simple, I guess. It's also super dumb when you could just do trapeziums. But in any case, all these rectangles have width 2, so we're just going to do 2 times the height of the first point, which is there, plus 2 times the height of the second one, which is there, and so on. That's what it means by this, by the way, with rectangles above your curve. I thought I was supposed to draw bat-like rectangles hanging downwards, but rectangles above the curve means doing this. Rectangles below the curve would mean going up to the previous point and then across and down, and up to the previous point across, and you have an underestimate. Anyway, calculate that, all of that, you get this. And then how could I make this better? By using trapezium rule, obviously, like any normal human being would in this question. Question 12, though, so we've got a parabola here, and a normal here and a tangent there. So let's differentiate that. Of course, that's what we're going to do. Half times 2 is 1, and then bring that down for a 1. At 0, this derivative is just minus 2. So the gradient of this line is minus 2, and it goes through 0, 0, so it's just the line y equals minus 2x. And then the normal here, now first we need to work out this point. So let's factorize this to be a half into x minus 4, which means solutions or roots to this equation are at 0 and 4, which is here and here, so this is 4. So at x equals 4, the derivative is 2, which means the gradient of the normal is minus a half, negative reciprocal, of course. So this is equation y equals minus half x plus c. Put in the information that you've got the point x is 4, y is 0, and you can calculate c to be 2, and so we get this equation here. To find the intersection between those two things, just set this equal to this. Solve that for x is minus 4/3, and then minus 4/3 times minus 2 is 8/3, and that's your coordinate of intersection just here. Could have used the other one as well. It's up to you. Kind of an interesting question here. So tan alpha is CT over AC. Just doing opposite over adjacent. Tan beta is CT over BC. Obviously, both have a CT in them, and the thing I'm trying to get to doesn't. So let's rearrange this to say CT is AC tan alpha and put it in there, and we get this. And now, again, this doesn't have an AC in it, so how can we get rid of the AC from here? Well, I can say AC is AB plus BC. And now all these things are found in here. I just need to make it look like this. So times everything by BC, expand out this top row, move the BC's onto one side, and then factorize them out, and then divide through, and we end up with this here, which is quite nice. So it's just a bit of rearranging, really. And then given that AB is this, just substitute all of that information in here, and you find BC is that. Find the height of the tower, that's CT, remember. We already decided that CT was this. I've been given BC is, or I found out BC is 69.8, and tan beta is just tan 20, so it's 69.8 times tan 20 for CT, which is going to be this here. Question 14 is about estimating gradients. Why should we not use 1.2 and 1.8 to estimate 1.4? Because 1.4 isn't in the middle of those two things. That would find an estimate for 1.5, so we need to be symmetrically decided. So 1.2 and 1.6 would be okay, but not for this. Calculate an estimate using 1.4 and 1.8. So yeah, we could either go in the middle, like 1.2, 1.6, or you can use this as one of the starting points and then something else further beyond, like they're doing here. So, okay, gradient is just change in y over change in x. So we're just going to do this one here minus this here, divided by this here, divided by this here. Sorry, minus this here. So change in y over change in x. It's the gradient. Type that in, you get this. For some reason, that's worth 2 marks, and the next one, which is exactly the same thing, is worth 1 mark. I'm not really sure what that's about, but anyway. And then she wants to estimate different curve at 1.4. Notice how these are symmetrical, so I should probably be using them. So let's do this minus this over this minus this, and let's get this as our suitable estimate, I guess, for the gradient. Very last question here. We're going to pick up a point for, or a mark, for plotting 3, 3, and 5, 7. So that was good. And the line this, now let's rearrange this by taking away x and dividing by 2. And we'll get this. So okay, it goes through 7 as the y-intercept, and rise over run here. So runs down 1, goes across 2. So I think those are the 2 points. Put a line through them, you get this, roughly. Verify this line is a perpendicular bisector of AB. So 2 things for a perpendicular bisector: needs to bisect, which means in the middle of the 2. So the midpoint of this is 4, 5, I believe. Does this go through 4, 5? Put in 5 here, put in 4 there, and you verify that it does, which is good. Is it perpendicular? Well, the gradient is minus 1/2. The gradient of A to B, again, change in y is 4, change in x is 2. That's going to be 2. These 2 things are negative reciprocals of each other, so they are perpendicular, and so it meets both criteria, and so it is the perpendicular bisector. Last thing is about an equation of a circle C, which has AB as its diameter. So therefore, the middle of AB is its center, which we've already discussed is 4, 5. So this is the equation of a circle. The center is 4, 5, so I can put that information straight in. The radius, now center 4, 5 to this point here, maybe at 5, 7. It's 1 across, 2 up. So do a bit of Pythagoras. 1 squared plus 2 squared is 5. So the radius is root 5. So radius squared is just 5, I guess you could say, which I think I do eventually. Determine the coordinates of P and Q where it intersects, the circle intersects the line. Well, I can see them both, but I guess that's because I got a computer to draw this for me. So maybe we should just calculate these properly. I took away 2y from both sides here and then shoved that result into here. To actually solve for the intersections, I wrote root 5 squared as 5. Expand everything out. Once you've simplified, remember these are double brackets here, so it's y times minus 5, and so on, both of these things. Simplify everything up. Divide by 5. This is another one that factorizes easily. Roots at y is 4 and y is 6. Shove these back into here to get x is 6 and 2, I think, which I can see my drawing is correct, which is good. The coordinates are 6, 4, and 2, 6. And I think that's the entire paper. Thanks for watching.